Let's we're going to talk about watering, the science and the art. Okay, so we'll talk about the science first, and then go to the art part. Uh, I show this. I show this. Not that I'm going to suggest that everyone go back and water with a hose. That's not the idea. But I think this sort of really talks about watering. It really talks about applying water to the plants, and so that's what I like about this. So that's really going to be the discussion. What I've found, over the years is watering is one of those subjects that it's really tough to teach. And there is some art to it, but there is some science. There is some things we can teach, and I think it helps us with the art. So sort of that's going to be sort of the approach. Now, we also talk about watering, and these terms we hear a lot. I hear them a lot. We talk about a wet grower, we talk about a dry grower, and I often get the question, what do you think? You think I should be a wet grower? You think I should be a dry grower? Well, I mean, I would consider myself more of a dry grower than a wet grower. But let's talk about the term the just right grower. That's the grower that we really want to be. That's the grower that you want. You want to be the just right grower. So get rid of those terms, wet grower, dry grower. Well, none of us want to be a wet grower. None of us want to be a dry grower. We want to be a just right grower. So I look at this, and you see these flats here, and watering these flats is, you've got one approach to watering flats, and then you go to these pots, and you got the hanging baskets, and so you go to another approach of watering. So these are sort of good examples of there's a difference in watering a flat and watering a pot. And then you look at this greenhouse, and I show this greenhouse because this is a multitude of stuff. You look at this. I mean, you've got porch boxes you got to water. You got these really tall combination containers you got to water. You got these pouches you got to water, and you think about water relations in that pouch, and that's from a science standpoint, I'd say that's a nightmare. And then you look at regular hanging baskets here, and then you got these other hanging baskets with plants growing around on the tops and the sides. So when we think about watering in the greenhouse, there's a multitude of different things, and so I think that's why the science part is sort of helps us a little bit of how you water. Uh, and then the other thing is that many of us we've had some classes or we've had some teaching of soil, water, and soils and stuff like that. One of the things that even in the college programs, most of the time we talk about soils, you take a soil course, and they very seldom ever talk about, container root media. And there's some unique terms that are pretty important when we come to container media. And one is gravitational water, container capacity, versus water table, water filled, and air filled pores are all sort of different when we talk about containers. And that's sort of as we go through this, these terms are going to pop up, and I'll try to explain them and how they fit this whole concept of container soils. And let's start with the science, because if it's easier to start with science in a way, because that sort of goes into the sort of, as I said, the art part of this. So this one is again, we'll start with the science of this may be this is the typical soils course. So I like this picture because it shows a lot of things. In field soils, we got a water table. You've got in this picture here, you've got this sort of pond over here with water in it. And as you get away from that pond, you see the water table changes. Now, there's a lot of things that happen there. As you know, the plants that grow around that pond are different than the plants that grow up here, what's farther away from the water table. So water table becomes really important even in field soils. And I think that's the concept we want to sort of go from this field soils to the container when we look at that. Now, you'll notice that in this how far you work from this groundwater or water table is pretty important. And if you look at a lot of fields and certain parts of North America, we actually put tiles in, even in field soils. We put tiles in to drop the water table to improve the crop growing. And I know in Indiana, there's a lot of cornfields, a lot of soybean fields that have been tiled to lower the water table so that we have higher productivity. So when you think about container soils, we're going to sort of use some of the same terms to look at soils and watering. Then you ask the question, what's soil? Okay, and I didn't change this because, as Brian said, this came long ago. But what's soil, or what's root media? And basically, we look at three phases. We look at a solid phase, that's the particles. We look at the water phase, that's sort of the water. And then we look at the gas phase, and you'll notice that the gas phase are sort of pockets of air in that soil, and then you've got the liquid phase that goes around that. So when you think of soils, you think of those three phases, and it's a combination of those three phases that make soil what it is, and for plant growth. Then you look at soil moisture, and this becomes real important because you've got a soil particle, and then around that soil particle is what we call hygroscopic water. And that's water that's held to that particle, and it's held so tightly that it's not available to plants. So hygroscopic water in soils, actually you know this, that soil can not be completely dry and the plant still wilts. And that's that hygroscopic water. It's not available to the plant, so the plant really can't use that. And plants use the capillary water, and that's the water-filled spaces that are in around that particle, but it's not held tightly enough that the plant can take it away. And then gravitational water is sort of the water that flows away, and we'll get to that when we get to container. But those three levels of water are pretty important, and as we talk about how it's held, remember how that water is held around each of the particles. And then we look at this, and sort of, I like this approach because you start with a container and it's only got air in it. Okay, so you got air in this container. Then you put the soil in, and the soil is sort of the particles, and then you put water in. So you've got a combination in a container. You've got a combination of a solid soil particles. You've got liquid, which is the water, and you've got gas phase. Now, the other thing that you can add here is you look at that container to the right with the soil, the water, and the air. And the thing is, what happens when you compact? The one thing you know is when you compact that, you're not going to compact the soil particles very much. So really what you're doing is you're getting rid of air. So as you compact soil, you really are reducing the air content mainly. So that's important when you think about packing soil in a pond or packing soil in some place. You're really reducing the structure, and you're mainly reducing the air structure. So the other thing that's important with soil is what we talk about, soil aeration. And if you think about soil that we're having plants grow in, you've got roots. And so the roots are living, and they're not carrying on photosynthesis, but they are carrying on respiration. So as they carry on respiration, they use oxygen and give off CO2. So if the roots are growing in there and there's no aeration, eventually they will use up all the oxygen, and they'll be completely carbon dioxide, which roots don't grow well in just plain carbon dioxide. So this soil aeration process is pretty important, and it fits into the whole watering concept that we'll talk about in a minute. So aeration, soil aeration, or exchange of gas within the soil and within the atmosphere is a pretty important concept when we talk about watering. Yeah, this one is sort of an interesting because it just reinforces exactly what I just said. If you look at atmosphere, if you look at air, it's mainly nitrogen. You actually we breathe mostly nitrogen. It's about 21% oxygen and about 0.03% carbon dioxide. Now that varies a little bit. It's as we talk about burning fossil fuels in the atmosphere and stuff. Actually, carbon dioxide levels have gone up over the last few years. But the point is that if you look at soils, that in air, those are really constant values. But then you look at soils and you'll notice that the roots, when you're talking about roots growing, the nitrogen not going to change because they don't really use nitrogen, but they use oxygen and they give off carbon dioxide. So if you've got a really soil that doesn't have any air exchange, eventually you get all carbon dioxide. And so the balance between carbon dioxide and oxygen is really, really important. And when we talk about that aeration part, then that's sort of where that concept comes about. Now, why is water important to plants? And I think we all know that, but it's important to think about that. The water, plants are almost entirely water. About 90% of most plants are about 90% water. Interestingly, I say every now and then that, really in the greenhouse industry, we are selling containers of water. We talk about, buying bottled water now. Some people sort of say we're using a lot of bottled water now, but actually, as we've sold plants, we've sold a lot of water. So it's sort of in a unique form, but you think about the plants you sell, think about you're selling 90% water. They use tremendous amounts of water. As you know, as plants grow, it's important. Transpiration stuff is important, so they use a lot of water. A lot of water goes through plants. And water really water is the sort of the lifeblood of the plant. So it influences everything about the plant. So water is a really, really important part of plant growing and plants, as they say. If you could look at a plant and you look at the plant on the left, if you removed all the solid parts, you would still see a plant. Because, as I say, 90% of the plant's water, and the other important thing, it forms a continuous phase through the plant. You know that if you break a stem, it very clearly shows you that you break that water column, and that's why the plant wilts. So it's important that water column is continuous through the plant. We'll talk about that as we talk about how water moves. So the thing is that the importance of water in plants is not a trivial thing. It's really a very, very important part of the plant. Now, you always say, I look at this and I sort of said, well, maybe I shouldn't show this, because it becomes, you never show a slide that you guys spend 20 minutes talking about. So I'm not going to spend 20 minutes talking about it. So what I'm going to do is highlight the three important points that I want to show here. One is water absorbed by the plants through the roots, as we all know. And we could spend a lot of time talking about how that occurs and stuff. But just to simplify it, we know that the water is absorbed by the roots of the plant. Water moves from the root throughout the plants in a continuous water phase. And this continuous water phase is pretty important, because all this is connected to movement of water and how water moves. And then water is lost through the plants, mainly through stomates. So most of the water is pulled through the plants, and this process is really, really important as we look at this continuous phase. Now, how does water move through the plants? Well, it moves through this continuous phase, and it moves by tension or by suction. And I'll talk about, tension in the sense of matrix tension. And if you think of the plant, if you think of the soil holds the water by tension. And so the plant has to have the ability to have tension it has to have lower potential, so it can pull the water from the root system, or from the soil into the root system and then into the plant. And so this continuous pulling of the water from the soil to the plant is fairly important. And I'm not going to talk about sort of the one thing that's really important, and I'm going to focus on just sort of matrix potential, is how water is held by the soil and how the plant takes it by matrix potential. But the water solute potential is really important in this movement too, and that would be a whole nother hour discussion of how all that works. But the point is that, as we know, you put fertilizer in water, you change the solute potential. And in the plant, you've also got sugars and things that again add to the solute potential. So the point is that water will move from low potential to a higher potential. So the ability for plants to take water from the soil is because of this potential. So the water potential is lower in the plant than it is in the soil. So then it moves from a low potential to higher potential. So that's sort of the important. But like I say, I'm just going to focus on the matrix potential because that's sort of the most important component in the soil. But the solute potential again is something that, you know, we could spend an hour talking about. Now, the thing is that this sort of, the reason I put this in is this sort of describes to me the you know, the wet grower, the dry grower, or the just right grower. If you take a plant and it's sort of continually deficient, and continually deficient means it's wilted, and if it's continually wilted, you usually affect plant growth, and so the plant's not going to grow very fast. Then if you look at the middle plot where it says periodic deficiency, the point is that, you know, you water it and it grows, and then you let it dry out and wilt. It will slow growth, and so, you know, you sort of, so the non-deficient is the just right grower. It's always applying the correct amount of water to the plant, so that you get continuous growth and non-deficient growth. So that's sort of you want to be that just right grower. Now, let's talk about, and I put this picture in because I'm gonna take this picture, and you see, it's my hand. I'm holding a plant that I dumped out of the pot, and so you see the root system, and the soil, and the root media. And I can flip that slide over so it looks like it's hanging in, and then with the magic of Photoshop, I can sort of suspend this container in space. And so just sort of give you the idea of this is Photoshop, so it's not strange hanging in space like this. But I've used this because this sort of can describe some of the things I'm talking about. Now, if I apply water to a pot and I get drainage out the bottom, the drainage is called gravitational water. So that's the water that just flows out of this soil matrix. Then once I water this pot continually, once I could totally water this pot to excess, I get water out the bottom, then I reach a point called container capacity. The point is here is the container capacity is no matter how much water I put on this pot, I can only get a container capacity because all the excess flows out the bottom. And it's a pretty important concept in watering to me, because the thing is that we'll talk about this a little later, but the point is once you get a container capacity, the plant has all the water it can hold. And if you keep putting water on, what you keep putting on runs out the bottom of the pot. So the other, and this one is the sort of the tougher science part of this, and that's the perched water table concept. Is in the container, when you water a container, you have a perched water table. And what a perched water table means is that the water at the bottom of that container is like a water table. And it hangs up there that it is exactly like that water table in field soils. So, and it doesn't matter that if I can suspend this container in air in you know, mid space like I've done, and if I water this, I get gravitational water on the bottom, and the bottom of that container still has a perched water table. What that means is the water in the bottom of that container has absolutely no water potential. It doesn't have any matrix potential. It's free water. So it's exactly like it was setting in just free water. So as you water a container, just remember that that perched water table is there. The water at the bottom of that pot has no potential. It's free water. Now, the thing is that you look at this, and as you get away from a perched water table, the amount of water and air in that root media changes. And you'll notice that in the bottom is you got more water and less air. In the top of the container, you got more air and less water. So the water potential throughout this column is different depending on whether you're in the bottom of the container or whether you're in the top of the container. And so if you look at this 6-inch pot, you see that the top of the container, the soil will always be drier. Will always be drier than the bottom of the container. Now, if you take that same media and you put it in that flat that I showed in that first slide, look at what the water relations will be. That soil will be much, much wetter than if you go back to look at this one, and this will be much drier up here. So you think about watering, and that's a pretty important concept, is you think about watering a short container, you talk about watering a tall container, you talk about a plant growing in a short container and a plant growing in a tall container. That air to water ratio changes tremendously because of this perched water table. And so that to me is one of the key things when you talk about container watering. So now let's go to the art. The art is sort of the fun part in a way. And the art is when do you water and how do you water? And the thing is that art is always one of those questions that I say it's difficult to teach art. I can teach the science part pretty easily. The art part is a little more difficult because art, I typically say that somebody has the art, or you can say it really bluntly and say you either have the art ability or you don't have the art ability. Certainly you can learn some of the art ability, but the art is the tough part to really teach. What are the watering variables? Root media is absolutely a variable. And you know that you can take a media that has bigger pore space, and it's much easier to water. It has better drainage. It doesn't hold water quickly and stuff. So we can change the watering variable by the root media. And that again is another probably 2-hour discussion of talking about all those factors. Container height, we've already talked about. The taller the container, the farther away it doesn't matter what the soil mix is, but the farther away you get from that perched water table, the difference in the aeration. And just the composition of the container. I can remember most of many listening probably don't remember the clay pot days, but I can remember the clay pot days, and we grew plants in clay pots, and then we went to plastic. And I can just trust me when I say it is much different to grow in a clay container than a plastic container, just because of the water relations. Plastic, you don't get any water out the side of the pot, and so the composition of the container will drastically affect watering. And then certainly plant type. If you're growing a succulent or you're growing a petunia, that makes a huge difference. You can't water them the same. Or even if you're growing portulaca and petunia, you can't water it the same. You can, but they don't like the same amount of water. The age of the plant, the size of the plant, obviously make a tremendous difference. The bigger the plant, the easier it is to water. So those are plant variables. And then environmental variables we sometimes forget about, but temperature, humidity, and light can make a huge difference. And the examples I can give you is early spring, spring, and late spring. Now, obviously, early spring, the plants are smaller, but also the environment is just pretty tough. The greenhouses, you got less light, you've got more cloudy weather, You've got usually higher humidity, and it's all those things that, so early spring, watering is much tougher in the greenhouse early spring than spring. And then late spring, by the time you get to late spring, we often are faced with, you just can't keep up with the watering. So watering becomes easier in late spring. This time of year is a tough time. This time of year is when that sort of the art of when do I water and how do I water becomes even more important. And then the root media we've already talked about, but the root media can have a tremendous effect. You can buy a soil that, and it's really the water fill to the air fill pores. It's a pore space that tremendously affects how much water holding capacity that soil has. And so we've already talked about difference between tall containers and short containers. So, in fact, maybe you want in a shorter container, you want a little more porous mix than you do in a great big container. And then it's a balance between air filled and water filled. And we want the soil to hold enough water so that it doesn't dry out completely, too quickly. But then I always bring up this greenhouse versus consumer question or customer question. And the thing is that the soil mix we grow in the greenhouse, particularly when you think of early spring, is a little more open because it's much better for us in the greenhouse, but it's probably not the greatest soil mix for the consumer in the middle of summer. So it is always this balance, and one we need to be aware of, at least think about. Then we come to skill and experience. Skill and experience is the one, and this is where really the art comes in. Often I say that the really good grower can really look at the crop and tell. And actually, just before wilting, and if you pay attention to this, you can see it, but just before wilting, the plants have a dull appearance. And that's something you have to develop an eye for. So I would encourage you to sort of, if you don't have that eye, work on trying to get that eye. Work on trying to look at the crop and get that feeling for that dull appearance, because that's when you need to water. It's just before wilting. The other thing is that some growers can touch the leaves, and they can tell a little bit about how turgid it is. And so again, touch, looking and touch is really, really important. And then obviously, I think all of us that water in the greenhouse, you lift the plant. You get a feel for how heavy it is, and you can almost tell. You can compare you look at the dull appearance, you feel the leaves, and you pick the plant up, and you can really fairly quickly tell that the plant needs water or not. How many times that I walk in a greenhouse, and how do growers tell when to water hanging baskets? You get the pole, you lift the plant with the pole, you see how heavy it is, and you decide you need to water or you don't need to just by weight. So weight is a really, really good characteristic of when you water. Now, some other things that I sort of are near and dear to me when we talk about watering is, I think each container, when you water, each container is water to container capacity. It means that you get a little bit of drainage. And I know there's been a lot of sort of suggestions that we need to save water and we need to minimize, outflow and et cetera. But I would argue that if I look at water relations of this container, that every time I water, if I water so every pond has container capacity, then everything is uniform. It's really tough to put on just enough water so you don't get any drainage, but to figure out exactly where that point is, because that I can tell you, and we all experience it, if you water in the greenhouse, with a spaghetti system, chafing system, you'll notice that you start putting water on, and some plants will start dripping before others. And so, there's differences between water content of those containers. And so, at least if you put the water on till you get container capacity each time you water. At least you start with uniform water content in all the containers at the same time. And then the other thing that I always like to do is I'd say watering twice. And twice, actually, I can tell you I have watered plants in this life a number of times. And I just have a habit is when I water plants, I water twice. I water once and I come back and I water the second time. So I make sure that everything is at container capacity when I'm done. And then the other thing is that with a lot of computer controls now, and with some of the drip systems, you water for a few minutes, then wait for a few minutes and water some more. And actually, some growers are doing this almost 3 times in a row. And the reason for this is you see this sort of drip stake here. Is the problem is that if this media is fairly dry and you put the water in, you got to be careful, because if you put the water all at one time, you can get some channeling, and so you get a center here that's really wet, but you're not getting a lot of lateral movement, so this container doesn't get all wet. If you water a little bit, you get this wet, you get a little bit of water out, and so then when you water the second time, you have a tendency to get more flow through the whole container. And that's why some growers will water a little bit, wait, so they wet a pretty big thing, water a little bit more, then they wet more, and then they'll wait, and then they'll water more so that they get the container capacity eventually. So multiple application of water becomes really important just from a physical standpoint of just making sure that you get this container completely wet and you get the uniformity of water in the container when you water. Now, overwatering is one of my sort of favorite comments, because overwatering, there's a lot of misconceptions to me about overwatering. Overwatering is watering too frequently. It's watering too often. If you look at the container, you look at all this science of watering, and you say that I put water on the container, I get a container capacity. If I put more water on, it's going to run out of the bottom. That's going to be gravitational water. So I don't overwater at one time. I can stand there for 5 minutes. I put water on the container, and once I stop, all the excess is going to run out of the bottom, and so it's not going to be overwater. You can't overwater. You overwater by watering too often, and that is, to me, for watering, that is just a huge concept. You look at this. I put water on. Once I get container capacity, that's all the water that container can hold. So if I keep putting water on, all that's going to run out the bottom, gravitational water. And so once I turn the water off, I'm still at container capacity. So overwatering is watering too frequently, not putting too much water on at one time. So that to me is a pretty important concept. And then I got listed here my very strong watering beliefs. And some of you, if you've seen me talk, is my after 3 p.m. in the afternoon. I really don't think you ought to apply water after 3 p.m. in the afternoon. Now, obviously, you look at North America, and this comment is not quite as important in Florida or California or maybe Texas, but certainly in the northern North America, if you say 3 p.m., the reason I say 3 p.m. is by that time, particularly in early spring and this time of year, 3 p.m. is beginning to get, pretty dark. And so I have seen plants actually at 3 p.m. in the afternoon. I've seen plants that are very near wilting. And by the time that you go into the nighttime in the early morning, those plants will not be wilted. They just don't lose water at night, and they sort of, humidity usually increases at night. The reason I say don't water it after 3 p.m. is simply so you don't want the plant to go into the nighttime, into the darkness, into the cooler, with wet leaves and a lot of excess water around, because that's just asking for a disease problem. So that's why my 3 p.m. question is, if it's 3 p.m., just don't water. Then the other thing, if you question, should I water or not? You go in, you look at ground. Well, say I'm really not sure if I should put water on or I'm not. The decision is always easy. Don't water. If you can't decide whether you need to water or not, the decision should always be don't water. Don't water until you're very sure that the plant needs water. Then my other big, obviously you've realized I've got a sort of several of these really big don't do's. Probably the worst mistake I see in watering is spot watering. Spot watering, I've always said, is like a house of cards, and if you spot water, you really need to change your thinking. And with the thing is, I would say about spot watering is the only exception is probably late spring is edges. Then yeah, sometimes you need to edge water as spot. But the spot water pots is probably the worst thing you can do. And if you need to spot water, sort the crop, because that's the thing is spot watering is only required when you got a lot of differences in plant growth. So and I'll add to this, I always say that a good growing practice is if you need to space the crop, sort the crop. And nearly all the time I see is when you're spacing is generally most crops, you've got a lack of uniformity in the crops. And you really need to get the small plants and the big plants separated, because then you can water them differently. If you keep those together, the variation is going to get larger. So I'm always a big proponent of when you space, sort. When you space a crop, take the extra time and put the small plants together and put the bigger plants together, and that will make watering so much easier. It'll make your life so much easier. And then I would say that I mentioned that I'm not proposing to use a hose to water, and if you are using the hose to water, you really need to automate it, because really the watering is probably the most labor-intensive job in the greenhouse, and it's one that really automation pays the bill. It's always the first job to automate. If you don't automate anything else in the greenhouse, automate watering. And most every case that I've ever seen with growers is that you invest the money in automate watering, and it pays for itself usually in the first season. And so you really want to automate the watering. And certainly technology is, we get back to, I talk about the art and looking and stuff, and certainly there's technology we're studying with, particularly with all the electronics now, to help you with this question of when to water. But I would say to you that all of those things are going to be tools that you can use, but the grower still has to look at the crop, and you have to understand that part of the art part of when do you apply water and how do you apply water. So I still don't think we're going to get robots that are going to replace the grower, particularly when it comes to watering, because there is some art, there is some science. It's pretty hard to make a robot figure out. Now, just to sort of begin to finish up here, is I've got some pictures that point out some of the science and art things I've been talking about. I love this picture from a teaching standpoint. I actually hate this picture from a production standpoint. What this picture shows is I talk about the spot watering and talk about the variation, and what you see here is a good example of geraniums that are rooted, that have very dry cells, okay? And then you can see even this cell's a little bit wetter because it has less roots, but then you've got these plants that really are not showing any roots that are pretty wet. How do you decide to water this set of plants? This is why rooting and uniformity of rooting becomes so important. The point is that if I watered this strip of plants, okay? And yeah, I'm either going, treat this plant well, and so this plant I'll water and keep it growing well, but I'm going to overwater these, and these ones that are unrooted are going to really get worse because they're going to be overwatered. So that's why when I say, uniformity of watering becomes real important. Uniformity of growth becomes real important, and this is what this shows. This shows that this is sort of that if you could spot water, it's still out to cards, but it's trying to figure it out. It's just almost impossible. I look at this crop, and again, my comment here is that when I see this kind of variability, if you don't sort this crop, it's impossible to water. You can't spot water here. And so what you're going to do if you water this with a boom and you water everything the same, you're going to overwater some, you're going to underwater, or you're going to overwater or underwater. So the only way you can uniform this is to sort it, and you should throw some of them away. But then you got the little ones that you need to water differently than the bigger plants. So my comment here is you either sort this or bring the dumpster in and throw everything away, because it's going to be a mess, and you'll never correct it unless you sort it so you can water separately. So that's my big thing about watering and sorting and getting plants that are uniform. I took this picture rather interestingly, and the reason I took it was to show that, just to sort of make another comment, but always suggest that if you're doing these confetti mixes, is you plant the 3 liners in the center of the pot, because they sort of grow together and they play together better. So that's why I took this picture. But then when I showed this the first time, I looked at it, something I didn't see when I took the picture was, you look at these 2 plants here, and there's a watering problem there. It's not normal to see algae growing on the top of the soil. And what does that tell you? I didn't, actually I took the picture, so I didn't see it when I took the picture. But then I say the picture, I would have loved to take these out, because I suspect that these 2 pots weren't draining well. There's something wrong with the drainage in them. And my point is that here, a good example of watering and how important watering is, those 2 plants will probably, I would almost bet those plants were never sold, simply because they were overwatered every time and they never reached marketable size. So watering is critical. Then you look at this plant, and it's sort of interesting to me because I talk about watering, talking about container capacity every time, and here's the case of where these are freshly planted geraniums. They probably don't need to be watered to container capacity because the roots aren't down, but you really need to water into that root zone. And this one is again an example too of careful watering, because the problem is, until you get roots into that root media, that cell that liner was growing in can dry out much quicker because you don't get good lateral movement. So watering becomes tricky in a case like this. Much easier when it gets to this stage. But the other thing you notice here too is, what does the watering do to soils? And you see this, it's subtle, but I see this over and over again. You see watering does compact soils, and so you get a little compaction. You can see it here. When you freshly plant stuff, the media generally is fluffier than after you grow in it for a while. So you are changing the porosity a little bit with just as the plants grow. Then if you look at this hanging basket would be a dream to water, right? Because you really can't overwater this. But then if you look at this one, you think this will be a little harder to water. I suspect that I could overwater this, and a lot of consumers could overwater this plant pretty easy. So watering again is one of those factors that are just extremely important for plant growth. And then you look at these plants outdoors, and this is sort of later spring, obviously. It's going pretty hard to overwater these. It's mainly keep enough water on them. So again, that environment greatly affects watering and how you water and when you water, and sort of that art of watering. And then you look at this greenhouse, watering becomes, I look at this and I shudder, because watering becomes a nightmare. Because you've got such a different environment on the top plants and the bottom plants. So watering is not simple. It does take a lot of art to figure it out. And then obviously we build greenhouses with the idea that shadows move, and I see enough greenhouses that shadows don't always move. And again, you talk about variability in watering, variability in plant growth. There's a lot of variables you deal with, and as a grower, you really have to pay attention to that. It's not just go and turn the water on, as we all know. And this one I put in simply because, again, to reinforce this perch water comment. Now, they raised these plants off this floor, and the reason you raise them off the floor is because the bottom dries out quicker, but you don't change that perch water table. The perch water table is still at the bottom of that pot. So the reason I put this in is, don't get the idea that if you raise this plant up, that you're changing that perch water table. When you water, you get container capacity here. You still got the perch water table at the bottom of that container. It's just simply that you raise them up so that the floor doesn't hold water as long. So basically you improve the drainage a little bit, but you do not change that perch water concept. So that's the reason I show that. And then you look at geraniums in this larger container. I would say that this is a little easier to water because of just a large container. Whereas you look at this hanging basket, again, you can't water the hanging baskets the same. You have to handle those differently. You look at this basket with this fiber container. Again, I mentioned containers are different, so the water relations in this container will be very different than a plastic pot. And then you look at this container, and then you look at this set of containers, totally different watering concept, totally different watering issues. So again, it's that uniformity and looking and seeing. And then I put this in just the flood floor, and just to put this to remind you, the flood floor doesn't change that science. Okay, so you still got the flood floor, you still got the same. It's just the water you're putting on the bottom and moving up, whereas on the other you're putting down. So you don't change that concept with capillary or sub-irrigation. So I just put that in because I knew probably somebody might ask that question, but the whole science stays the same. So summary. Root media, porosity makes a huge difference in water holding capacity. Plant size and environment are variables that make a huge difference. Water just before wilting, dull appearance. Water, pause, water more, double water. I still say water, double or triple water, particularly with a lot of the automatic watering systems, is pretty important to get uniformity of watering. Overwatering is watering too frequently, not putting too much water on at one time. The 3 p.m. question, you shouldn't water after 3 p.m. And then I would say automatic water application is really, really very important for everybody. So automate, if you're going to automate anything in the greenhouse, the first thing you spend money on to automate is automatic watering. So with that, this sort of gives you at least my take on the science and the art of watering.